Hello there and welcome back. Tonight we will journey together into a realm of quiet cosmic beauty as we explore Fall Asleep with Uranus, the sideways ice giant's gentle mysteries, vertical bar facts about Uranus. Let us settle into a soothing mindset, letting our curiosity guide us through the serene blue-green glow of a planet that has long captivated astronomers and dreamers alike. As you rest in a place of calm, imagine peering across the vast darkness of space and seeing the softly glowing orb of Uranus in the distance, faint yet majestic on the edge of the visible solar system, about 2.9 billion kilometers from our Sun. We might softly echo Fall Asleep with 7 tranquil wonders of our sideways ice giant vertical bar facts about Uranus for a moment, and allow these words to gently set the mood, bringing our awareness to the unique and remarkable traits that define the planet's existence. Tonight we will explore how this planet rotates nearly on its side, forming a curious angle exceeding 90 degrees from the plane of its orbit, an astronomical quirk that gives Uranus its characteristic sideways spin. Because of this tilt, what most planets accomplish in a single rotation relative to their orbit, Uranus extends dramatically, presenting entire hemispheres of sunlight or darkness for many years at a time. Instead of simply rotating with a slight inclination like Earth's 23.5 degrees, Uranus leans at roughly 98 degrees, so that for a full portion of its 84-year journey around the Sun, one pole is bathed in sunlight while the other dwells in a shadowed winter. This means that a single season on Uranus, such as summer or winter, might last an incredible 21 Earth years, culminating in an overall 42-year cycle of sunny or dark polar extremes. Picture that extended twilight, as though the days or nights stretch out beyond comprehension, and realize how different life would be if you lived on one of Uranus's many moons. Allow me to lead you deeper into that image now, the quiet ring system arcing around this softly luminous planet, composed of 13 delicate rings that reflect the sun's light in subtle ways, flickering for the Voyager 2 spacecraft that flew past in 1986. With that in mind, let us explore the subtle, mesmerizing color of Uranus, a gentle blue-green shade that hushes the senses and invites us to dream of floating clouds and swirling mists. This color hails from the methane in Uranus's atmosphere, a gas that absorbs the warmer reds of sunlight and lets the cool blues filter back to any observer, giving the entire planet a pale, calm, ethereal hue that can lull us into a restful reverie. But there is more to Uranus than meets the eye. Beneath that tranquil facade stirs the coldest planetary atmosphere in the solar system, with recorded temperatures nearing -224 degrees Celsius. As we gaze upon Uranus from a distance, our perspective might be drawn to that veneer of methane haze, but we must remember that below those upper layers lies a complex atmosphere of hydrogen and helium, swirling currents and storms. Uranus technically belongs to the same class as Neptune, the so-called ice giants, not gas giants like Jupiter and Saturn, meaning that these two siblings contain large amounts of heavier elements in the form of volatile ices such as water, ammonia and methane. Far within the planet, a mantle of slushy water ammonia ocean might hide, wrapped around a small rocky core. Some scientists speculate about exotic phenomena that may occur under the extreme pressure and temperature of those deep layers, where carbon atoms might form diamonds that sink slowly into the planet, raining inward and perhaps collecting around the core. Though these visions remain primarily hypotheses, they remind us how the cosmic environment can reshape ordinary materials into forms beyond everyday experience. Uranus, like an understated teacher at the outer boundary of the solar system, patiently offers us puzzle after puzzle about how planets form, how collisions can alter their orientation, and how life forms might adapt to conditions we can barely imagine. To understand why Uranus looks and behaves this way, one prominent theory holds that long ago in the early solar system, Uranus may have experienced a massive impact with another protoplanet, some object roughly Earth-sized or even bigger, that knocked it sideways, forcing its axis to tilt wildly. Another possibility is that repeated smaller collisions could have accumulated to tip Uranus to its current orientation. Regardless, such an epochal event eons in the past seems to have left its mark, giving the planet the distinctive sideways spin that sets it apart from every other planet we know. Try to picture the aftermath: swirling clouds of icy debris reforming into rings, faint lumps of matter coalescing into the 27 known moons that circle Uranus. Those moons, named mostly after Shakespearean and a few Alexander Pope characters, Titania, Oberon, Ariel, Umbriel, Miranda, and many more, each have their own mysterious features, such as strange ridges, cliffs and canyons. Some are brighter, some dimmer, some more geologically active, yet all revolve in a dance around their planet, which in turn glides around the Sun in its wide elliptical orbit. The length of one Uranian year amounts to about 84 Earth years, so each of us on our home planet would see Uranus return to the same point in the sky once or maybe twice in a lifetime. Now imagine being on one of those satellites, gazing at the bright northern hemisphere drenched in sunlight for decades, then slowly drifting into an extended night. It is a world of extremes, yet also a world of elegant subtlety, from the pale color to the graceful rings to the gentle hush of its softly shining presence in the sky. While Jupiter and Saturn capture much of the attention in astronomy discussions for their swirling storms and majestic ring system, Uranus is more reserved, seeming to whisper rather than shout. Perhaps that sense of quiet is one reason it was not recognized as a planet by ancient civilizations. Unlike Mercury, Venus, Mars, Jupiter, and Saturn, planets visible to the naked eye that have historical records going back millennia, Uranus is somewhat fainter, requiring a more discerning eye or the right equipment to truly identify it. It was discovered by William Herschel in 1781, an event that caused much excitement in the scientific community of the time. Since then, we have gradually come to appreciate its unique qualities, culminating in the single historic flyby by Voyager 2 in 1986, when our robotic emissary gave us the first close-up images of Uranus, its rings, and many of its moons. Those images revealed a surprisingly featureless planet at visible wavelengths, though further study uncovered subtle cloud bands, swirling storms, and even transient bright spots that might have been storms deeper in the atmosphere. Over time, we learned that Uranus radiates relatively little heat in comparison to its siblings, leading astronomers to ask why it does not produce the same robust internal heat that Jupiter, Saturn, and even Neptune do. Is it possible that the cataclysmic collision early in its history released much of that heat, or somehow stifled the internal processes that would normally drive convection and storm activity? These are the kinds of questions that Uranus quietly poses to us, stirring an undercurrent of fascination. As we dwell on this sideways ice giant, we can reflect on how wide the solar system truly is. From Earth, Uranus requires a telescope or good binoculars to make out, appearing as a faint point of bluish light. You might imagine, in a dark countryside sky, scanning gently from one star to another, then pausing on that subtle celestial body shining with a pale glow. If you could block out the influences of city lights and let your eyes adapt, you might just perceive that this faint star is in fact the faraway ice giant that orbits at 19.8 astronomical units, the average distance between Earth and the Sun multiplied by almost 20. When you contemplate that, it is humbling to realize the scale of our cosmic neighborhood, and to appreciate the sense of peaceful isolation that Uranus must experience. It is not as far as Neptune, but still well beyond the orbit of Saturn, so that the sunlight falling on Uranus is less than 1% of what we experience here on our own planet. Yet that sunlight, dim as it is, still shapes Uranus's weather, chemistry and season. Let us journey now to the ring system of Uranus, which was first hinted at in 1977 by observations of starlight blinking out as Uranus and its ring edges passed between the Earth and the star. Later visits and studies confirmed the presence of at least 13 rings, somewhat faint and narrow, quite different from the glorious broad rings of Saturn. They are made of dark particles that might be lumps of rock, dust and ice, possibly remnants of shattered moons. Some of the rings appear to be shepherded by small moons whose gravity helps maintain the ring's shape, confining the particles so that they do not disperse across space. These rings, thinner and less luminous than Saturn's, provide Uranus with a certain understated grace. Gently drifting around the planet, they add to the sense that Uranus is quietly extraordinary. As you envision them, you might compare them to fleeting cosmic brushstrokes, arcs of dust that circle the planet in the faint starlight, capturing glimmers of sunshine and releasing them back into the cosmos in waves of muted brilliance. Moving beyond the rings, we come to the 27 known moons that revolve around Uranus. Each one has characteristics that speak to how dynamic these far-flung places might be under the right circumstances. Titania and Oberon, the largest, are battered by craters, and might harbor layers of ice and rock. Ariel has one of the youngest surfaces among the major moons of Uranus, signifying some degree of geological or cryovolcanic activity in the relatively recent past. Umbriel appears darker and more cratered, and Miranda stands out with some of the strangest topographical features ever found, including enormous canyons and a patchwork of ridges. Astronomers suspect that at some point Miranda might have been shattered and reassembled, or experienced intense tectonic and cryovolcanic forces that left a bizarre surface. The inner moons, smaller and numerous, dance in complicated orbits that can sometimes intersect the rings, playing a gravitational interplay that keeps the entire Uranian system in a subtle evolving balance. As we take all of these details in, we might recall that Uranus shares similarities with Neptune. We consider them twin ice giants, but the two have distinctions in color, weather patterns and magnetic fields. Uranus's magnetic field is itself a puzzle because it is tilted and offset from the center of the planet, which might be due to currents in the magnetosphere of Uranus. Typically confounds planetary scientists because it is so oddly oriented, leading to a geometry that can open and shut to the solar wind in unusual cycles. In that sense, Uranus becomes a quiet frontier for future exploration. At present, no spacecraft is on the way to Uranus, but many in the scientific community express interest in sending an orbiter there, complete with atmospheric probes, to unravel the mysteries that Voyager 2 could only briefly glimpse. If such a mission were to occur, it might show us the hidden storms in the atmosphere, the structure of the interior, and the untold secrets of those rings and moons. For now though, we can only imagine drifting near the planet, letting ourselves appreciate its calm presence, the soothing pastel cyan color, and the feeling of unveiling knowledge in gently falling layers. Beyond the scientific data lies a realm of cosmic poetry. Uranus reminds us that not all wonders come wrapped in blazing storms or swirling stripes. Sometimes, the wonders are more subdued and introspective, as though designed to reward the eyes of patient observers who know how to tune into whispering rarities. The planet's slow, nearly silent spin is a timeless dance, taking 17 hours and 14 minutes or so for a single rotation relative to the stars, yet with that axis laid so far over that it's almost rolling around the sun. In connecting with Uranus, we can tap into a sense of cosmic slow-mo. It is a place where the concept of day and night merges into something unusual for half of the Uranian year. One pole stares at the sun while the other is cast in darkness. Yet near the equator, the pattern of day and night might roll by in more typical intervals, albeit overshadowed by the changing tilt as the planet travels around the sun. The seasons themselves must be deeper and more profound than anything onward. Imagine a decades-long twilight transitioning into a hazy day, or a lengthy dawn that stretches over months as the planet orbits. That subtle progression might create breathtaking skyscapes and climate shifts in the tenuous icy atmosphere. Although we have not stationed satellites or landers there, we can still dream of the environment that an observer on Uranus might experience: the faint ring arcs crossing overhead, the panoramic sky tinted by diffuse sunlight, the swirling top of the atmosphere drifting in slow currents far below, and perhaps the gentle spark of auroras, if the planet's magnetic field interacts with the solar wind. Aurora on Uranus, while much less studied than those on Jupiter or Saturn, does exist, manifesting as luminous curtains near the magnetic poles. Yet because the magnetic poles are shifted relative to the rotational poles, the entire geometry becomes a fascinating tapestry of charged particles. In many ways, Uranus is an unsung masterpiece in the solar system's gallery. The planet pulls together an unusual orientation, a tranquil shade of blue-green, a cold faint rings, numerous geologically varied moons, and an odd magnetic field, all of which collectively encourage us to broaden our view of how planetary systems can form and evolve. Another subtle detail to note is that Uranus's brightness as seen from Earth can occasionally shift in minor ways, possibly influenced by changes in the cloud tops or in the distribution of methane haze. Like many planets, Uranus is not a static ball, but a dynamic sphere with an ever-evolving climate, albeit on timescales and magnitudes that differ greatly from our terrestrial world. This sense of living vastness can be comforting as we drift into a sense of wonder, letting our minds roam freely in the gallery of cosmic marvels. By focusing on these details, we cultivate a gentle appreciation for the incredible diversity of worlds beyond our own. Let yourself reflect on how improbable it seems for a planet to be struck or shaped in such a way that it ends up rolling along its orbit on its side. That tilt might have placed unique constraints on the formation and evolution of the moons and rings, sculpting them into the patterns we see today. It is possible that some of these moons hold pockets of warmth or exhalations of volcanic or cryovolcanic activity, as we see in other icy satellites across the solar system. If so, that further expands our sense of curiosity about whether such bodies might harbor the basic ingredients for life. We have learned that life in our solar system is not just restricted to Earth-like conditions,
Some of the icy moons further in, such as Europa and Enceladus, might have hidden oceans. Could some of Uranus's satellites be similar in that regard, or too cold and inert to host chemistry that is sufficiently complex? These are questions we cannot yet decisively answer, that they remain a part of that gentle tapestry of speculation that Uranus inspired. The planet's very name might evoke a sense of whimsy. Mythology, though in Greek tradition, Uranus was the primal sky father. As one of the earliest cosmic deities, Uranus gave rise to the Titans, including Saturn or Cronus, and eventually Jupiter or Zeus. But in scientific terms, Uranus served as the seventh planet discovered, adding a new dimension to humanity's map of the heavens. That event, in the late 18th century, signaled that our solar system was vaster than we had previously understood, a revelation that broadened our cosmic perspective. Over the centuries, we learned more about Uranus's composition, spin, and place in the grand structure of planetary science. In your mind, picture that sense of stepping outward from Earth, crossing the orbits of Mars, the asteroid belt, Jupiter and Saturn, then reaching an expanse of space where the sun's warmth fades to a more subdued glow. There, Uranus floats in quiet majesty, rotating in its peaceful sideways manner, waiting for us to discover more about its 13 rings, 27 moons, and invisible swirling winds. Breathe gently and sink deeper into this story, letting it carry you into tranquility. Our conversation about Uranus can be a journey that soothes you toward rest. Think of the pale sunlight gliding across the planet's upper atmosphere, occasionally illuminating subtle banding or swirling patterns in pastel blues and greens, revealing fleeting storms or differences in methane concentration. Also imagine the planet's shadow drifting across its rings, creating ephemeral patterns of dark and light in the dusty arcs that circle Uranus. Let these images wash over you in a calm wave of celestial detail. If we shift focus to the idea of traveling there one day, we might envision a shining spacecraft approaching the planet, cameras rolling, capturing the faint ring structures, analyzing the composition of the atmosphere from orbit, scanning for thermal emissions, collecting data on the magnetosphere, and sending back transmissions of unimaginable vistas. Over time, the spacecraft might drop small probes into the atmosphere, allowing them to drift deeper to measure temperature, pressure, and chemical composition. They might witness layered clouds made of hydrogen sulfide or ammonia crystals, gliding through the gloom. These hypothetical visions remind us that even at the edge of our known frontiers, new revelations await. Some theories suggest that by studying Uranus, we may gain insight into exoplanets across the galaxy, since many exoplanets discovered orbiting other stars may have sizes and compositions comparable to Uranus and Neptune. The more we understand our own backyard, the better we can interpret data from distant solar systems. Thus, Uranus is not just an isolated oddity, it is a key puzzle piece in the cosmic mosaic of planetary science. We wonder if the processes that shaped Uranus's tilt also happen elsewhere. Could there be exoplanets tilted on their sides just like Uranus, or even more extremely pitched, leading to even more dramatic visual changes? Perhaps so, and that possibility brings us closer to an understanding of nature's creativity on a grand scale. In drifting through this gentle reflection on Uranus, we can also recall the planet's rate of rotation. One day on Uranus is shorter than an Earth day, at about 17 hours, but that day-night concept is overshadowed by the massive tilt. We could turn our attention to how that interplay of rotation and tilt affects the wind pattern. Observations revealed that Uranus has wind speeds that can exceed hundreds of kilometers per hour, though less intense than some storms on Saturn or Jupiter. Still, Uranus is by no means static. Despite that calm outward beauty over the centuries, even centuries beyond our own time, Uranus will continue drifting around the Sun, completing slow orbits and rotating in a gentle sideways manner. If at night you ever point a telescope at the planet, you might be rewarded with a faint disk of bluish color. Some advanced amateurs have occasionally witnessed subtle details, bright spots from storms or changes in the planet's upper layers. The knowledge that we have gleaned from the planet so far is shaped largely by its solitary 1986 Voyager 2 encounter, though further observations with the Hubble Space Telescope and ground-based telescopes have provided glimpses of changes in Uranus's cloud tops over the years, including some surprising storms. Yet overall the planet remains overshadowed by the more easily observed Jupiter and Saturn or the intriguing Neptune. Uranus thus stands as a gentle giant that invites our patience and quiet curiosity. Allow these thoughts about Uranus, from the faint wink of its ring arcs to the subtle swirl of methane haze, to guide you to a relaxed state. In this stillness, we realize that the cosmos is vast, and each planet we have encountered has proven more diverse and surprising than we ever predicted. Uranus is a bright example of our incomplete knowledge. Initially thought to be just another planet in the outer region, it turned out to have a system as elaborate and puzzling as any other. If you let your mind linger, you might even envision drifting near the planet's day-night terminator line, where the ring of hazy sunlight meets the quiet darkness. Gently swirling patterns of clouds forming in the troposphere, silent storms gathering in the frigid air. Consider the sense of timelessness as Uranus completes its rotation, and how that rotation does not align with the orbital plane in the way you would expect. This dissonance becomes a quiet wonder, teaching us that there is no absolute blueprint for planetary orientation, that chance collisions or other cosmic events can reshape a world's entire geometry. In that sense, Uranus is an embodiment of cosmic resilience. It continues orbiting around the Sun, carrying its retinue of moons and rings, forging a path that is both recognizable in its planetary qualities and singular in its sideways spin. As you relax, feeling the weight of your body gently sinking, drifting off into the wide ocean of rest, absorb a deeper layer of wonder for you. Consider the longevity and breadth of its seasons, the calm and glacial pace at which the planet's face changes. It reminds us that not everything in nature operates at the frenetic scale that we see on Earth. Instead, Uranus stands as a testament to slow change, subtle color, limitless time. The planet's discovered in 1781 lit a spark in astronomy that carried onward. Herschel's decision first was to name it Georgium Sidus, George's star, after King George III. Thankfully the name, though it took time to be recognized, aligned the planet with the mythological traditions that had preceded it. In stepping back, we can appreciate how that small historical footnote ties Earth's own cultures and histories into a broader cosmic timeline. Now, if you imagine yourself drifting away from Uranus, back into the comforting darkness of interplanetary space, you can let each exhalation carry you toward a calm acceptance of the universe's greatness. Our sideways-eyed giant is a spectral beacon at the outer reaches of the solar system, reminding us that even at great distances from the Sun, wonders persist. The planet might not generate the vivid storms or swirling hexagonal patterns seen on Saturn, but it tells its own story through quiet extremes. We have discovered that it is smaller in diameter than both Jupiter and Saturn, but has a greater tilt. We have discovered that its atmosphere registers the coldest known temperatures in our solar system. We have discovered that its rings are narrower and darker, yet no less captivating. We have discovered that its family of moons are as varied and interesting as the Ring. Uranus stands as one of the 4 giant planets, yet is somehow set apart in a category of its own, not just scientifically but also emotionally, inviting deeper contemplation of how each planet is shaped by a cosmic event. As you continue to listen and sink deeper into relaxation, consider how this gentle planet will influence your sense of cosmic time. With a year lasting 84 Earth years, we see that so much can happen between its returns to the same point in its orbit. Generations of humans come and go in that span, while Uranus continues in its cyclical path, unconcerned with our fleeting time frame. This humble reflection can bring a sense of peace, an assurance that while our personal experiences may be brief, we are part of a broader cosmic tale that extends through unimaginable decades, linking us to everything else that orbits the Sun. Eventually, if we send another craft to orbit Uranus, capturing data, imagine the gentle slight intensifications in storms or differences in ring brightness or moon surface shifts. Over decades we might watch as the polar region that was once in the dark emerges into the light, and the once sunlit region turns away. We might track the first glimpses of new phenomena in the deep atmosphere, which might respond slowly to the changing sunlight. This is how we do science at the scale of Uranus, patiently, letting nature's rhythms unfold. But for tonight let us hold on to these images, the smooth cyan hue reflecting through the blackness of space, the ring circling at gentle angle, and a hush reminiscent of distant cosmic breezes. Beyond all the technical details about magnets, ring compositions, moon there's a simple and calming presence here. A planet that almost begs us to drift into a restful state and contemplate what if you would make it if this or what and discovered. Think of how you felt as we set out, an eagerness to explore the facts and features of you. Perhaps a bit of curiosity about how a planet can be so different, and now a sense of closeness, as if you can feel the calm, unhurried sea. That feeling, reminding you. In the hush of night, as you close your eyes, you might hear the faint echo of that the time. The Tamilian dance, the timeless swirl of an up. You may picture the 42-year cycle of near-endless daylight, evoking images of an infinite polar dawn. Evoking images of an infinite polar dawn or perpetual. Now that we have wandered so far, let us softly begin to wind down, carrying with us the quiet knowledge that Uranus has shared. We have learned of its subtle rings, delicate yet significant, and its family of 27 moons, named after literary characters, each with its own personality. We have recalled the powerful collision that likely tilted the planet, giving rise to its extraordinary axis and the seasons that last for decades. We have imagined ourselves drifting in a cold methane haze, in a place where the sun's warmth is faint, yet enough to shape elaborate atmospheric movements. And all the while, the serene hue of Uranus, that soothing cyan, has accompanied us, reflecting a calmness that might remind us to be still and rest. Thank you for joining me on this journey through the tranquil wonders of our sideways ice giant. I hope that contemplating the distant and peaceful realm of Uranus has helped you to relax and find a gentle space in which to drift off. Let these thoughts flow into your dreams, full of quiet rings and subdued colors, swirling in slow motion across unimaginable distances. May your rest be deep and renewing as we close this evening's exploration. Good night, and I wish you sweet and restful sleep.